All right, let's take a look at today's lesson. So today we're going to be working with trig derivatives. Yay! I know, I love trig so much. So I know you've just been really wanting to have more formulas to memorize, and here we go. We've got more. We've got 6 different trig derivatives. What I'm going to do is I'm going to go through and I remember them by patterns. So I'm going to help you think about this with patterns. So what I do is I memorize these two as a pair. These two are a pair. So the derivative of sine is cosine, and the derivative of cosine is negative sine. So those I remember together because they're quite similar to each other. The other two, so I actually do all these in twos. I memorize these in pairs. The derivative of cosecant actually has it in it. It's negative cosecant cotangent, and the derivative of secant also has secant in it, secant tangent. Okay, and then the last two, I group these together. The derivative of tangent is secant squared, and the derivative of cotangent is negative cosecant squared. Okay, so that's how I group them. Now let me get a little bit more detail about them. One thing to note is that the derivative of a trig function that starts with the c is going to be negative. All the trig functions, the derivative of all the ones that start with a c, are negative. So that's a pattern that you should remember. That will help you. The others are not. So if it starts with a c, it's going to be negative. Also, if you think about our Pythagorean identities. So let's just write them out here just for fun because they are so fun. Okay, so we've got sine squared plus cosine squared is 1. And if I divide everything by sine, I've got 1 plus cotangent squared equals cosecant squared. And then divide everything by cosine, I've got tangent squared plus 1 equals secant squared. Okay, I want you to notice see where these are blended together? Cosecant, cotangent, look, they are together. They're like buddies. And see the cotangent, the cosecant, they're together, right? They're together in the Pythagorean identities, and they're together in derivatives. These tangents and secant, see how they hang out together? Well, look at them, tangent and secant and tangent and secant. So hopefully that helps you link those functions together in your brain. That's what we're working on, and we're working on ways to memorize these. All right, so questions so far? All right, so now let's work on some derivatives. And as we do derivatives, the question that I want you to ask yourself is, what rule am I going to use every time? What rule am I going to use? Why do I say this? I say this because what I find students making up rules. They just kind of make it up on the fly. I guess, I don't know, they're doing their own rule, or they don't remember the rule. I don't really know what's going on. But there's always a rule, always. There's never a time where you can just say, let's do it this way this time. It just doesn't work that way. So we're looking at, and I think about them as templates. Okay, I think about them as templates. So we basically have 3 templates. We've got the product rule, we've got the quotient rule, and we've got the chain rule. And we haven't learned the chain rule yet, so we won't be doing any chain rules today, but these are our rules. These are the templates that we choose from when we're doing derivatives. So as we look at this first example, we have to ask ourselves, what is going on? Is that a product or a quotient or a chain? And I hope we can see it's a product, right? There's there's a implied multiplying there. So this is going to be product rule. And the product rule is, and I write it down when I'm working derivatives, it's FG plus FG, first things first, second things second. Okay, so here we go. Let's go for it. So we've got y prime equals. So I take the derivative, and let's just label this. This is f, and this is g in my formula. So the derivative of f would be 2x, copy paste g, which is sine, plus. Okay? Copy paste f, so x squared. The derivative of sine is cosine. And I know you wish we could do more stuff to it, but there's really no need. We will just leave it like that. And that's our answer. Could I do more stuff? Sure, I could factor an x out, but would that shrink that derivative in any way? Not really. It would just make it look different. It wouldn't really shrink it. When we simplify things, we're looking to shrink them. We're not just trying to write them in a different way, just as gigantic as they were before. We're really looking to shrink them. Okay, we doing okay? All right. Let's look here. And actually, what I would like to do, I'm just going to do it right here. I need to talk about something that you're going to encounter. So let's just make it a different color. So let's just say like sine squared. Let's say y is sine squared. So the first issue with this one is we're not really sure what's going on. Right now, we would rewrite this as sine times sine. We could use the product rule with that. Later, in the next lesson, we're going to learn to write it like that, because it's sine times sine is sine squared. We would use the chain rule with it. And I'm just going to leave that for you to think about. We're not going to do them. Yes, I could do it right now using the product rule, but when we learn the chain rule, it would be a faster process. Does that make sense? So yes, I could totally do the product rule with no problem, but we're going to wait. Okay? All right, so let's look. We've got a couple of examples down here. So I'm going to ask myself, what rule would I use? I've got product, quotient, and chain. Quotient, and I really don't have a choice. I've got to do the quotient rule because this denominator is not a monomial. You remember those words? Monomial means one term. And if it was a monomial, I would totally try to write this as not a fraction. I totally would. Not that I don't like the quotient rule, it's just a much more complicated rule than the product rule. But this is a binomial. There's two terms, so that would be impossible. I can't rewrite it, so I'm not going to bother. We're going to have to use the quotient rule. So let's write it out. So that's fg minus fg, first things first, second things second, over g squared. That's my quotient rule. This top right here is going to be f, and this bottom right here is going to be g. That's according to the formula. According to the formula. Are we okay? All right, so let's do the formula. So we've got f prime of x equals. So the derivative of the top, the derivative of f, our secant would be secant tangent. Then we copy and paste the bottom, 1 plus tangent x, the g. We'll copy and paste, minus. Is everybody with me? Okay, now f, we copy the top, which is secant, and then we take the derivative of the bottom. The derivative of 1 is 0. The derivative of tangent is secant squared. All over 1 plus tangent x squared. And you might be thinking, oh, great, I'm done, let's move on. Do you think you're done? No. There's probably stuff we can do to make this more simple. It's trig, so you know there's ways to make it more simple. So I'm going to show you the steps that I went through. You might have taken different steps, but we would have ended at the same place. I'm going to go ahead and distribute this because this is just, I mean, that's not, I can't do anything with it trapped in there. And I'm going to, multiply those together. I'm just going to get rid of the parentheses. So secant tangent times 1 is secant tangent. And secant tangent times tangent is secant tangent squared minus secant times secant squared is secant cubed all over 1 plus tangent x squared. Okay, well, it's looking better. It really is looking better. So what I'm really looking for when I'm trying to simplify, we know we can't add those together, right? I've got some squareds and stuff. Let's remind ourselves up here. Let's look at this. See how 1 plus cotangent squared is cosecant squared? And then we've got tangent squared plus 1 is secant squared. I think I might be able to get some traction. Let's just see what's going on. So I'm going to leave the first term alone. And I'm going to factor a secant out from the last two terms. Okay, I'll pause here for a second. How are we doing? So I want to go back and look at that Pythagorean identity. Okay, I'll pause for a second. So let's go back and look at the Pythagorean. I got tangent squared minus secant squared. Could I turn this into, what would tangent squared minus secant squared equal? -1, right? So tangent squared minus secant squared, I would move these over and it would be -1. So I'm actually going to, this portion right here is going to turn into a -1, which would be way nicer than what I have, isn't it? Way nicer and a lot smaller. We're looking for smaller. So f prime of x would be secant x tangent x plus, actually minus secant x all over 1 plus tangent x squared. Okay, so let's talk about simplification. Could I factor out a secant from the numerator? Sure. Would that get me anywhere? Is tangent minus 1 going to help me in any way? No. If it was tangent plus 1, it would, wouldn't it? But it's not. Could I multiply out the denominator? Sure. But is that going to make this expression bigger or smaller? Bigger. We don't want bigger. We always want smaller. So we're really going to leave it alone. That's how we know when we stop. Students are always like, well, how do I know when to stop? Well, you know when to stop when you can't make it any smaller. Nothing you can do can make it smaller. That's when you stop. All right, so we're going to stop. And that's going to be our answer. Okay? All right, we got one more. We ready? Yes? Okay. So we look at this and we ask ourselves, what template am I going to use? Now, I will tell you, I see two properties up there, don't you? You see division and multiplication, both of them. And I will tell you that the overriding one, if you're choosing between division and multiplication, is going to be the division one. That's the template we're going to use. And, oh, this is exciting. We get to do multiplication inside of the quotient one. Wow! Great, right? We can have embedded formulas and inside other formulas. This is fantastic. So Okay, so it's a fraction. The overriding one, the template we're going to use is quotient rule. And then we're going to have to insert product rule inside of there. And y'all are like, oh my gosh, you're crazy. Okay, so here's F, and here is G. And this is my quotient rule. So FG minus FG, first things first, second things second, over G squared. Here we go. So F prime equals. The derivative of F, the derivative of the top thing, is cosine. I copy and paste the bottom thing. Minus. Okay? So then I copy and paste F, so sine times, I'm going to take the derivative of the denominator. The derivative of 1 is 0, but the derivative of this is a product rule, right? That's a product. And I'm going to just put over to the side, that's FG plus FG, first things first, second things second. Okay, so we're doing the product rule inside of the quotient rule. This is so exciting. Okay, so the derivative of F, so this would be F and this would be G in my product rule scenario. So that would be F and that would be G. Okay, so the derivative of x squared is 2x, copy paste the sign, plus, copy paste the F. The derivative of sine is cosine. All over 1 plus x squared sine x squared. Let me just say you should rarely ever multiply that bottom one out. Just don't even bother with it. If you can't, yeah. You might be able to take something out of it, but you really should not multiply it out. Okay, so let's see what we got going on. Do you think we can leave it like this? No, we cannot. So I'm going to get rid of the parentheses. That's always what I do first, just to see what's going on. Cosine times 1 is cosine. Cosine times x, cosine, x squared sine would be, and I'm just going to put the x squared first, x squared, and just put the trig stuff after. It's multiplying, so it doesn't matter, right? It doesn't matter. Okay, so then I've got sine times sine, so I'm going to leave that out. Sine times sine is sine squared. And then minus, and then again the x squared I'm going to leave out front. X squared sine x cosine x. All over 1 plus x squared sine x squared. Okay. Do we see anything that's like speaking to us? We do, right? We can, aren't these the same? One's positive and one's negative. Can't we get rid of them? Sure, we sure can. And so now I've got f prime of x is going to be, so I've got cosine minus 2x sine squared all over 1 plus x squared sine x squared. Okay. What do you think the possibility of getting the numerator to be 1 plus x squared sine? That's not going to happen, right? So there's no sense in trying to do anything else. Could I change sine squared to 1 minus cosine squared? Sure. Is that going to help me get smaller? No. No. So we're just going to leave it just like this. We're going to leave it alone. All right. How are we doing?